afternoon, my YouTube viewers. It is Crystal here, and I wanted to make another video for you. In the last video, I was talking about Module 3 of the course Probability and Combinatorics, and I converted it over to Python. And in this video, I'm going to take the coursework and I'm going to convert it to Excel because I want people to have an opportunity to be able to solve these problems in both Python and Excel. And the reason why is because Python is a very popular programming language, and you can use Kaggle or you can use Google Colab to program in Python for free. You can also get a free Python IDE and install it on your computer as well. And in addition to that, Excel is a spreadsheet program that virtually all businesses have, and most people have to know how to use Excel to work in an office. So that's why I'm doing this probability and combinatorics in Excel. So the first thing we're going to do is, the first question is, describe the sample space for tossing a fair coin followed by rolling a single fair die. So your coin is going to be heads or tails, and your dice is going to be 1 to 6. And we'll just say okay, and then how you do it is how we get the sample space. You can calculate the sample space manually, and in the course that I took, everything was done manually, but you want to utilize the functions in Excel to be able to do it. So basically, you have a $sign for and dash $B for, which gives you H1, so that's heads 1, and then you copy and paste that down all the way to 6, and that will take you down to H1 to H6. And then basically the $signs by the A4 indicates that it's an absolute reference. And then for the tails, it's exactly the same, so it's going to be $A, $5, and dash and B4, and then you're going to have T1 to T6. So what you have is you have a sample space of 12 elements, and that's what the sample space looks like. So now we have a question that is very similar to the previous question. It is, describe the sample space for an element which consists of choosing a boy or a girl, followed by the chosen candidate picking one of 4 teams, say soccer, debate, tennis, or crew. And so that is done exactly the same way that it was done in the previous question. So you've got your gender, it's going to be either a boy or a girl, and your team is going to be SDTC for a soccer, debate, tennis, or crew, and I don't know what crew is. So it's going to be done exactly the same. Equals $A, $15, and dash $B15, and then you copy and paste that down to 4, and it'll give you BS, BD, B10, BC, and then that's for a boy. And then for a girl, it's going to be equals $A, $16, and dash $B15. And so now you're going to get a GS, GD, GTC, GC. And so that's your sample space. And so in this instance, your sample space is composed of 8 elements. So we have our last question is, how many elements would you expect to have in an experiment that involved tossing 2 fair dice? What would this sample space look like if it were described by means of ordered pairs? And so again, it's exactly the same. You've got die 1, which 1 to 6, and die 2 is 1 to 6. And then you can determine what your sample space is 6 times 6 is 36. So your sample space is going to have 36 elements to it. And so you use exactly the same format for 1, 1. It's going to be $A, $24, and dash $B, $24. And then you copy and paste that down to number 6. And then for number 2, it's exactly the same. $A, $25, and dash $B, 24. And you copy and paste that all the way down to number 6. For number 3 is $A, $26, and dash $B, 24. And then you copy that all the way down to number 6. And for number 4, you have $A, $27, and dash $B, 24. And you copy and paste that down for number 6. So for number 5, it's going to be $A, $28, and dash $B, 24. And then you copy and paste that down all the way to 6. And then $A for number 6 is $A, $29, and dash $B, 24. And you copy and paste that down to 6. So you've got 1, 1 to 6, 6. And so you've got 36 elements in that. Okay, so now what we're going to do is we have a question regarding candy. A candy bowl contains 8 lemon drops and 5 gumballs. Jim selects one candy and then selects a second candy. The tree diagram shows the possible outcomes. What are the values of X and Y? So the value of X is a lemon drop in the first tree, the first branch of the tree, and the value Y is gumdrop in the second branch of the tree. So what I'll do here is we'll just say right here, we'll say X is a lemon drop in the first branch, and Y is a gumball in the So there we go. So you can see what the X and the Y is. So the number of lemon drops is 8, and the number of gumballs is 5, and the total candy is the lemon drops plus the gumballs equals 13. So the probability, my thinking is much clearer than my typing. The probability of a lemon drop in round 1 is basically, the formula is B5 divided by B7. So that's going to be 61%, or 8 divided by 13. And then the probability for a gumball in the second round is B6, because you know the first time they didn't select a gumball, they selected a lemon drop. So it's going to be B6 divided by B7 minus 1. And the reason why it's B7 minus 1 is because you've already taken one piece of candy out. So that's why it has to be B7 minus 1. So it's going to be 5 divided by 12, or 41%. So that's how you solve that problem. Now we're going to do a coin toss. We say a fair coin is tossed 3 times. What is the probability that 3 heads will turn up? Define the probability of getting heads in a single toss. So the probability of heads is 1 divided by 2, so that's 0.5. And then the number of coin tosses is 3. So the probability of 3 heads is B4 to the power of B5. So that's going to be 0.125 or 12.5%. Probability of 3 heads. So that's how you solve that question. And now we've got a question concerning dice. What is the probability of rolling an even number on a 6-sided die? So you've got 3 even numbers on a 6-sided die, so the probability is going to be 3 divided by 6 or 0.5. What is the probability of rolling a 2 on a 6-sided die? So the probability of 2 is going to be 1 divided by 6 or 16.67%. So what is the probability of not rolling a 2 on a 6-sided die? So there's 2 ways that you can do it. I'm going to show you one way. The probability of not rolling a 2 is going to be 1 minus B7. So it's going to be 0.8333. But if you said there's going to be 5 divided by 6 is also going to be 8.333. But I think what they want to do when you're calculating probability is they would rather you say 1 minus B7. I think that's what they want. But if you wanted to say like equals 5 divided by 7, so, and what we're going to do is we'll just say alternative method. But I think the way they want you to do it is going to be 1 minus B7. So that's it for our questions for Module 3 of the course Probability and Combinatorics. So where you, rather than doing the problems by hand, you're going to use Excel to complete the problems. So thank you so much for watching my video. If you like my video, please like and subscribe. And I will be making another video for you very soon on a technical subject. So watch this space.